Part 2, geometry, triangle. For triangle ABC, angle A plus angle B plus angle C equal to 180. Can you explain why? Students can go back to lecture 1 that we introduced the names of all these angles. Angle 1 and angle A or angle 2 are alternate exterior angles. Between two parallel lines, angle 1 equal to angle 2, which is angle A. So this angle 3 and 4 are the same. They are also alternate exterior angles. 3 equals to 4. So now angle A is here. Angle B is here. And in the middle is angle C. This is a straight line. This is a straight angle is 180 degrees. So that the angle A, B, and C add together comes up to 180 degrees. Number 2. For n sides polygon, the sum of the interior angles is 180 degree multiply n minus 2. Okay. So if we have a triangle, the side number is 3, right? And we know that the 3 angles of a triangle adding up is 180. So 180 is actually multiply the side minus 2. That is 180. If they have 4 sides, we can add one line in the middle to change them into 2 triangles. So 1, 2, 3, that's 3 angles adding together is 180. You have another triangle, that's another 180. So the side number is 4. So 180 multiply the side number minus 2, that is 360 degrees. Okay, we can do this for any size, any number of sides, just using interior lines to separate everything into triangles. And you count the number of triangles, then you multiply that by 180. Number 3, the sum of any 2 sides of a triangle is greater than the third side of a triangle. So let's draw a triangle. If we have A, B, and C. Okay, so that says AC plus BC is greater than the length of AB. So let's look at one extreme case when AC plus BC equals to AB. When they equal, this point C will land right on the line of AB so that AC plus CB equals to AB. Then there won't be any triangle left, right? The point C has to rise up from line A and B. So the minimum is greater than the line of AB. And the difference of any 2 sides is smaller than the third side of the triangle. I want a student to play with this idea. You look at the difference. What's the minimum that you can have? Well, given you still have the triangle. Number 4, the area of a triangle is 1/2 multiply base multiply height. What do you mean by base and height? So if we call this one base, that is B, the height is going to be the opposite. You have the base here, the opposite vertex. You draw a vertical line. This would be the corresponding height of your base. We can have multiple vertical lines here. They are all in pairs. If this one is the base, this is the height. If this one is the base, this will be the height. For 2 triangles A and B that both have the same height, triangle A, we have another triangle B. If they have the same height and their area is proportional to the size of their base, it's only because the triangle area is 1/2 multiply base multiply height. If they have the same height, their proportional, the area, the proportionality is going to depend on the size of the base. Let's look at some practice problems. Problem number 7. Find the value of x in the diagram on the right here, this angle x. So to find angle x, we kind of need to know angle 2 and angle 4, right? How do we find angle 2? We know that these are opposing angles. So angle 1 would equals to 65 degrees. Now you know angle 1, right? And this triangle has if you add the 3 angles up, it's 180 degrees. This is a 90. You know this one is 65. Now you can find angle 2. Once you find angle 2, let's try to find angle number 4. To find angle number 4, there are 2 different ways, or maybe more than 2 ways. First, you have, this is a straight line. You have 90 degrees, you have 72 degrees. Total, this straight line is 180 degrees, right? Then you can find angle number 3. Once you find angle number 3, then you can find this big angle by using, this is 180 again. 180 minus the 51, you can find this angle. And 3, 4, and that big angle adding together is another 180. Now, subtracting these 2 out, you can find angle number 4. And again, this is another straight angle, which is 180 degrees. Minus 2 minus 4, you will get to angle number x, angle x. There's a different way of doing this. 51 degrees actually equals to the sum of angle 3 and 4. Why is that? Because angle 3 plus angle 4 plus the big one, let's call that 6, equals to 180 degrees. And 51 degree, which is on the outside of the big angle 6, also equals to 180. Therefore, this outside angle equals the sum of the 2 inner angles. So angle 3 plus 4 equals to 51. So once you have that, you know angle 3, you can easily find angle 4. Practice problem 8. This triangle ABC is isosceles right angle, right angle triangle. AC equals to 20. Find the area of the triangle ABC. And if AC equals to x, can you express the area ABC using the variable of x? Okay, so we know the base. Now we need to find the height. So I already draw the line here, BD, that is perpendicular to the base of AC. So the area of triangle ABC equals to 1/2 the base multiply the height. So we use the name for that line, and we also have a line on top, which means that's the length for this part. So AC we know, we need to find BD. So let's look at this triangle. This is an isosceles right angle triangle, right? So AB would equals to BC. And then we draw a perpendicular line here. Also for isosceles right angle triangle, this is 45. This is also 45. And why is that? Because this side equals to this side, and you have a 90 degree. So these 2 angles has to equal because they are totally symmetric. The 3 angles add up to 180. So these 2 would split the remaining 90 degrees. So each is 45 degrees. Then you draw a perpendicular line here to separate them into 2 identical triangles, right angle triangles. In this case, you have 45 degree here. These 2 are identical. This is 45. That is 45. This is 45. To have, for a right angle triangle, then you have 2 angles are the same, which is 45. Then you would have their sides would be the same too. So these two would equal to each other, and these 2 would equal to each other. So this is a half of the AC, and so BD is also half of the AC. So BD is half of AC. So if AC, the length of it, equal to x, we can write the area as 1/2, this is x, multiply BD is 1/2 of x. So collecting the terms, that give you 1/4 quarter of x squared. Then x equals to 20. Students can plug in the numbers to find the answer. Problem 9. Triangle ABC is a right triangle. AC is 40, BC is 50, AD is 24. Find the length of AB. So I can think of two ways of solving this problem. One is more basic. For right angle triangle, we have A, B, and C as the sides. We have the property of c squared equals to a squared plus b squared. Students can always use this to do it manually to find all length of the sides. For example, this right angle triangle, you have this side is 24, this side is 40. We can find out this one. So DC squared plus AD squared equals to AC squared. That is DC squared plus AD, that's 24 squared equals to 40 squared. Students can carry this out. Once you know the DC, the total is 50. Then you can find the BD. Once you find the BD, here is a right angle triangle too. You know BD, you know AD, then you can find AB. So you can find out all length for this triangle. Then you can find out what's the length. You'll find out the length of AB. There's a different way of doing this. So since this is a right angle triangle, the area of ABC, this is the second method, can be equal to 1/2 length of AB multiply the length of AC. Or the area of this can be written as 1/2 base as BC. Now the height is AD. We know BC, we know AD. We don't know AB, but we know AC. But these two equal to each other. We plug in the numbers, we divide this thing by AC and multiply 2, we'll get to AB. This way is relatively easier, but using this property, for sure you will find out the answer, but it just takes a little more time. Practice problem 10. The area of triangle ABC is 15. CD is twice as BC. Find the area of ACD. We have a very similar problem in lecture 1. We hope that the students can do this by themselves. Remember, you have the base. This is very close to a vertical line. So you draw a height. Base multiply height divided by 2. That's the area of a triangle. For ACD is the same case. Your base is here, you have the same height, so that the area is proportional to the length of the base. We have just talked about that property. So I'll leave this one for the students to figure out.